Okay guys, we're doing lesson 7. Let me get it on the screen. Okay, so they're going to give us just more complex radical equations. That's all we have going on here. It's the same stuff as lesson 6, it's just a little bit harder. Okay? Okay, so everybody's with me? And there's only like 2 pages of this, so we're going to go slow and we're going to take it easy and we're going to make sure everybody understands this. Okay, so Billy here. He's given a radical. Billy solved the equation incorrectly. His work is shown. Explain where Billy made his error. Okay, so what did Billy do on the very first step? He moved this negative term to the other side. Do you agree? And he switched the negative to a positive. So was that step okay? Yeah. I think so. Now he wants to square both sides. Do you agree? So on the left, the square and the square root cancel and you just get the radicand. Is that okay? All right. Now on the right hand side, what did he do? All he did was square this and square this to get 9 and a plus 1. Do you see that? That's incorrect because he needs to use distribution. He should have had this term repeat itself and then FOIL it out. Okay, so don't make that mistake. Don't be Billy. And we got to show the correct work. So let's pick it off where he left off. So we had, I'm picking it off from right here. I will in just a second. Okay, so I'm on the third line, and I just copied it. That's all I did. I'm on the third line, and all I did was just copy it. Pardon me? So the left-hand side we said was good, so I'm just going to get that down. Now the right-hand side we have to do the distribution. So we have 3 plus root a plus 1, and then 3 plus root a plus 1. So when you see the square, I'll use my pointer. When you see the square, and basically you know you have to square. It's part of the process. Now if you're squaring monomials, you just square it. But if you're squaring binomials, you have to use distribution. So it's like for the square step, you know, be careful for binomials. Just a little reminder. Because that's probably the only place you'll have a hiccup, unless it's like some arithmetic error. Okay, so the right-hand side, and with the help of the FOIL, what's the first? Okay, and what's the outer and the inner? Because those are the ones that are going to be weird. The outer is 3 root a plus 1, and it's going to happen again because it's a perfect square. Do you remember how the middle term doubles up? Do you remember we talked about that? And then the last one, careful. When you have a square root times the square root of the identical thing, they cancel, and then Jolene finishes her text and gets back on task. I love it. Gotta get that text finished and get the mind on the math. So we didn't finish, or we didn't touch anything on the left. All we did was distribute the right. And you can see the FOIL first, the outer and the inner come together. So the first, the outer and the inner come together, and the last. So how does the outer and the inner come together? You know how sometimes we break down the middle term? So now we're putting together the middle term. Sometimes we break it down, sometimes we put it together. Good. Didn't touch the left. And we have Right here is a 6 and a root a plus 1. Because basically we just have 6 of those objects, and those objects happen to be root a plus 1. Now what about the f, the first, and the l, the last? Those you need to simplify. So what's 9 plus 1? And you have the a as well. Okay? So I just put the first and the last in there as well. Everybody okay with the 9 plus 1 is 10? What's 9 plus 10? Sorry, my son does that like at least once a day. Yeah. I know, it's so bad because my son does it. Okay, before I start the next step, I got distracted. You have to, now that you have done all this amazing work, you've isolated, you've squared, and now you're trying to solve, but another radical popped up. So you have to isolate it one more time. So this guy, let's just keep it on the right because it's positive. So let's move the 10 and the a. So we're going to be subtracting 10 and subtracting a, and we get 2a minus 6. Okay. Now we want to square both sides again. So we square and we square. Now, the right-hand side is a monomial, the left-hand side is a binomial. So for the right-hand side, you literally just square it. So you have 36a plus 1. I hope that you remember to square the coefficient. Some people might forget that. You must square this. That's a power of a product. You have to square both terms. And what does it say up here in red on the whiteboard? Be careful for binomials. So we have to do this FOIL. Okay? So perfect square, right? So the first one will be 4a squared. The last one will be 36. And how does the middle term work out? You'll have a negative 12a and a negative 12a for a negative 24a. And in this course, you're going to be doing perfect squares so much that I think it's okay that I sort of skipped an intermediate step there. Now at this point, all you have is a degree 2 polynomial. You have no radicals anymore. How to solve degree 2 polynomial? What does one side always have to be? And that you cannot forget. Starting now. You have to just make a pact with me that you're going to remember how to solve degree 2 polynomials. One side is going to be 0 and the other side is going to have the positive a square or whatever. So see how this is positive? The lead coefficient's positive on the left here. So let's put the 0 on the right. So before we do that, let's just distribute that 36 so nobody's lost. Just put that in. And now you just have a bunch of terms that you can move around. Okay. So how's that 36 going to come over? As a negative? So negative 24 and negative 36 makes negative 60. And you're going to minus 36 and minus 36 and get 0, which is nice. And now this one's very easy to factor because there's no c value. So it's not one of those ones where you have to find the magic numbers. All you can do is the GCF factoring. That's all you can do. So what can you take out? Probably a 4a, and you get a minus 15. Now solving this, for sure a is 15, and do you remember what happens when you have this one? Daoud remembers. Anybody else remember? This is that zero product law, remember? Zero product law. If you look back, I think it's lesson 5. When you have a monomial with a variable, a is 0. Now we have to check the validity of both of these answers because they may not be correct. So let's verify. Look at all that good work. Okay, verify. What's the original question? Root 3a plus a 4 minus a root a plus a 1 equals 3. Plug in 0, you get root 4 minus root 1. 2 minus 1, 1 equals 3. No, I can't. Does 1 equal 3? No, this is a contradiction. That's like when you're butting heads like this. Contradiction. So this is, what's the proper word? You being extra? So now you have to check 15. It does, if one of them's rejected, it doesn't guarantee the other. Okay, so let's try 15. I'll go up this time. If that was 15, that would be 45. 45 plus a 4 is 49. If that was 15, you'd have 16. 7 minus 4, is that 3? Okay. So, A15. Wow is right. A lot of work. You have to be very, no, you can't just do it in your calculator. No, we can't do that. In dash 2, you can just go to a graph and find these answers. In dash 1, you have to show all this process. Now, if you're starting to feel like I wish I could just do the graph and just check my calculator, then you're probably starting to realize that maybe you're more suited to the dash 2 stream. And there's nothing wrong with that, you guys. It's like sort of a coming of age thing. You're like, you know, one of the biggest issues that we have in schools right now is that the kids are in the wrong courses. So I know you always want to push yourself and you try to keep all your doors open, but really, like, if you're trying to get into a science program or an engineering program, like dash 1's for you. And yeah, you know, if you're really not going to have like a math heavy career, you probably don't need dash 1. But whatever, enough of that. Let's try a class example 2. Oh my gosh, they don't even give you the equation. You have to come up with it on your own. So we're going to go through this one slowly and translate the language into the words. Okay, the square root of 2 less than a number. How do you write 2 less than a number? Is it 2 minus x or is it x minus 2? 2 less than a number, and we'll call that number x. Which one is it? Hey, there's nothing wrong with being wrong. It's part of the process. Are we agreed that it's x minus 2? Okay. So when this square root of x minus 2 is subtracted from, okay, so we have to subtract root x minus 2 from something. Yeah, because we're subtracting that from something else. So what are we subtracting that from? 5 more, so 5 plus twice that number. So let's just write it normally, 2x plus 5. That's challenging. That's a lot of language. Okay. Now let's see if it's true. I'll use my pointer. 2 less than a number. So if the number was 10, would 10 minus 2 be 2 less than that? Yeah. And that thing, this whole thing right here, is going to be subtracted from this. 5 more than twice a number. 5 more than twice the number. Okay, that's pretty tough. Now I guess we have to solve this. Oh, is it equal? Oh, the result is 3. So this, all this stuff equals 3. Now how are we going to solve this? Are we just going to square both sides? Should we just don't write anything down yet? Should we just do this? Yeah. I'll just give you a tip, just from experience. It's just easier to do these binomial expansions when there's only one radical. When there's two radicals, it gets pretty dicey. Okay? So I'll just give you a tip. Put one radical on each side. I challenge some of you to try to do it like this. That'll be fun. Might have a page and a half of algebra. Which one do you want to move over? Good. So let's leave the root 2x plus 5 on the left. And let's move that guy over to the right. And now we will square both sides. Square and square. The left is very nice. So yeah, you think of it as like, if you could just isolate one of the radicals. Just isolate one of them, and then you're going to lose the square root sign. And then you can focus on the other side. And eventually you'll have to probably do this twice. Okay. Are we comfortable with shorthanding the perfect square? You're going to get a 9 on the first. Remember the first. And the last is going to cancel out for a nice x minus 2. Now it's the outer and the inner that are the same, and so therefore they double up. Six root x minus 2. Good. And it's all plus. And if you don't see that, then you are a person that would be okay with writing it twice and then doing the FOIL. Okay? These guys always double up. Because this 3 is going to times that basically, because it just repeats itself. Now, again, you want to isolate the radical again. Isolate again. So this red star and this blue star mean the same thing. And then you have to isolate again. Oh my gosh. So is the radical positive? So let's leave it there. Let's move the other stuff. So we're going to minus a 9, and we're going to add a 2. Let's just deal with the numbers for now. What's minus 9 plus 2? Well, doesn't really matter. Let's just put that over here. Minus 9 plus, oh my gosh. Minus 9 plus 2. So that's gone. This is gone. And we still have to get rid of that x right there. Agreed? Okay, we got rid of the numbers. We moved them over. We still have that x to move over, so how do I get rid of that positive x? Negative x. Okay, so on the left-hand side, you need to simplify that. On the right-hand side, we've isolated the radical. So what's the left going to be looking like? 2x minus 1x is x. 5 minus 9 plus 2. 7 minus 9 minus 2. You guys okay with that? Now what do we do? Square it again. Oh, I've seen this before. 36 x minus 2. The left-hand side you have to use FOIL. You're correct, Shakim. You have to use distribution. So x squared Positive 4 are the front and the end. How does the middle double up? It'll be x times negative 2 twice minus 4x. What do we do with the right-hand side? What's 36 times 2, Mahad? Remember in the homework, same thing. Now we put all the stuff where? Why? You want that x squared to be positive, right? And how do you solve degree 2 polynomials? One side has to be 0. Choose the side where x squared will still be positive. Any questions on how I got 40 and 76? How did I get 40? Minus 4 and a minus 36 gives us minus 4, and an adding 72 gives 76. Now we have to factor. This one is a nice factoring because the x squared is got a coefficient of 1. How do you know it's 38 and 2 so fast? You tried on the calculator. That makes sense because 2 would have been the very first thing you would have guessed, right? Yeah, you start with 2. If 2 doesn't work, then try 3. If 3 doesn't work, then try 4. You're just looking to divide, right? So you did 2, 76 divided by 2, he got 38. So it made sense. And both of them have to be negative. So this gives us 2 answers. Are they both okay? We have to verify. Okay, plug it into the left-hand side. Let's start with 38. 2 times 38 is 76. 76 plus 5 is 81. Minus 38 minus 2 is 36. 9 minus 6, 3. Okay, 38 works. Now check 2. 2 times 2 is 4 plus 5 is 9, root 9. Minus root 2 minus 2 is 0. Root 9 minus 0 is 3. Does 3 work? Boom. So what's the solution? Both. Okay, so here's the reality. Once you verify, both could work, one could work, one couldn't work, it could switch, and neither of them could work. Those are the different possibilities. Okay, you have all of the rest of the block to figure your life out. If you were to maximize your time, I would start 1 and 2 for sure. If you get done 1 and 2 and you have a little bit of time left, I would probably skip 3 because you have to really think about 3 and 4 and 5. So when you have a lot more free time at home, maybe you got the lights dimmed, you have a fresh coffee, there's no distractions, do 3, 4, and 5. Because those take problem solving skills. Whereas 1, 2, 6, and 7, it's just formulaic and algebraic. So 1, 2, 6, and 7 for the rest of the block. Do 3 and 4 and 5 at home. And there's a group work thing at the end. That's up to you if you want to do that. Sure. So please use your time effectively for the rest of the block. And good luck with your equation solving. And moreover, we are done the unit. So tomorrow will be the practice test, and then Thursday I'm going to give you a review, and then Friday we will write the test.